Hey everyone, welcome back to just another great edition of Organic Chemistry. Today we're going to be just kind of working on practice problems, just because at this point I feel like that's the most helpful way to feel comfortable with it. So I'm going to do all 12 of these. Feel free to do as many of these as you'd like. But I definitely, if you're not understanding it, it's always nice to kind of see somebody work through these problems. So that's what I'm going to do. Hopefully you'll notice with all of these, there's a lot of similarities in terms of how to do the thing. Okay. First things, there's two things we need to know before we can kind of get started. First thing we need to know is you should feel comfortable with all of these 10 organic prefixes. The first four are kind of weird: meth, eth, prop, and bute. So if you have one carbon, you name it meth. If you have two carbons, you name it eth. Three is prop, four is bute. So like for example, um, in this first guy here with three carbons, prop is going to be the prefix that we use. Now, there's more to it than that, but that's kind of where we're starting. Um, the other thing you're going to need to know is suffixes. So remember with single bonds, it's ane, which is ane, that's how it's pronounced. Double bonds is ene, which is pronounced een. And triple bonds, yne, we pronounce that ein. So ein, een, and ein are our suffixes. So for example, on this first problem, I wrote down prop because I saw three carbons. I'm just going to put that there. And then I'm going to write down ein because I'm going to see here between the carbons are just two single bonds. So there's no double bonds, there's no triple bonds. There's nothing really to worry about there. Then, remember the last part is sometimes in front here, you'll have to put in a number. In this case, since we don't have a double bond and we don't have a triple bond, we don't need to put in a number. So for this problem here, we are done. That's awesome. For the second problem, you'll notice that it's also all single bonds. So actually, I'm going to switch it up a little bit, and I'm going to say that ane is going to be my ending first, just because I feel like it. Then the next thing I'm going to have to do for the second problem is I'm going to have to count up the carbons. 1, 2, 3, 4, 5, 6. 6 carbons, if we look back at the list, that is over here, it's hex. So I'm going to write down hexane. And again, in this case, I don't need to put a number in front because I don't have a double bond or a triple bond. That's not true for problem number 3. Problem number 3, it looks like it's got 1, 2, 3, 4 carbons. 4 carbons is, it looks like but it's not. Remember, it's called bute, as in like butane, the stuff that you use in like a butane torch to light, I don't know, stuff on fire. So bute is going to be my prefix. I've got a double bond here. So remember, for double bonds, I use the prefix, or I use the suffix, sorry, ene. So it's going to be butene, ene. Now, one of the things you'll notice here, let's change the color and zoom in a little bit on butene, is that I could number these outside to in. I've got the first carbon on the end, and then the second carbon is kind of on the interior there. So in this case, since the double bond is between this second carbon and this second carbon, um, or if you're numbering it from left to right, it's on the second carbon. If you're numbered from right to left, it's also on the second carbon. So I'm going to put a 2 here. You would never, never, ever, ever would you put a 3 here. You would never say 3-butene. Um, in things with 4 carbons, it can only be 1 or 2. If it's got 6 carbons, for example, like here, the highest number you can have is 3, because think about it. If you're numbering them from one way to the other, the highest number you can really get is 3. So yeah, just be careful with that on the numbering. Okay, question number 4. This has a lot of carbons. Let's count them all up, see how many we have. I'm going to count from the opposite way, just so you guys can get used to seeing, you know, counting done in multiple different ways. Okay, that's 8. So let's zoom out here and let's take a look. What do we call 8 carbons? There it is right there. 8 is oct. So oct. And then we do have a double bond here once again. There's my double bond right there. So that's going to be ENE. Now we just have to kind of go through the process of numbering everything. So I'm going to do that real quick. 1, 2, 1, 2, 3, 3, 4, and 4. So you'll notice here that since I've got a lot of carbons, I can have higher numbers like 3 and 4. But what you'll notice is that the double bond here starts on the second carbon and ends on the third carbon. So since it's starting on the second carbon, we're going to write down 2-octene as our answer. Hopefully what you'll notice about these names, these numbers, is that most of the time when you do use a number, they tend to be low. And even if you look at these other guys over here, the numbers are like 1, 3, 1, and 4. So again, the numbers are pretty low. And you will see here when we do have a high number, it's because we've got dec, which remember, dec, the prefix for that is 10. I'm going to start explaining these a little bit less and just kind of go over them so you can kind of see how I would do these. Again, I'm going to still kind of, show the work that I was showing. 1, 2, 3, 4, 5, 6, 7. 7 is hept. We've got a triple bond. So for triple bonds, we use YNE. And then it looks like here it's between the second and the third carbon. So we would call this 2-heptyne for that one. Moving on to the next problem. 1, 2, 3, 4, 5. That's pent. Pent is 5. And again, we have a triple bond, so we're going to use YNE. And then I tried to trick you once again. I wanted you to say that it's 3, but it starts on the second bond. So we would, or the second carbon from the right to left. So we would call that 2-pentyne. Okay, a little bit different now when we've been given the names and we're asked to draw, just because there are multiple different ways to kind of make this correct. One thing you're going to want to make sure when you're drawing stuff out is if I've got bute, that means I have 4 carbons. So then what I'm going to do next is I'm just going to make sure that everything has 4 bonds coming off of it. So let's take a moment just to check that. This carbon, 1, 2, 3, 4 bonds coming off of it. This guy's got 1, 2, 3, 4. And then kind of so on and so forth. You can see that all of them do in fact have 4 bonds coming off of it. The easiest way to do that is to kind of, if you saw what I did when I drew this, the first thing I did is I just kind of connected my 4 carbons together. And then the next step that I did is I just kind of put one up, down, side to side. So in this case, it's already got side to side. It's just up, down, up, down, up, down, side. Just to make sure that everything's got its proper number. The last step here is just to fill in the hydrogens. Since everything here is ending ANE on this problem, I just need hydrogens. I don't have to worry about double bonds, which is kind of nice. So I'm just going to take the time right now to fill in all these hydrogens. And then I'm going to make this just a little bit smaller so that it's less in the way for the next problem. Oh no, dang it. That's okay. Perfect, out of the way. Okay, the next problem is hexane. That's also going to be all single bonds here because I'm noticing that it ends in ANE. So again, I'm not going to think about this a whole lot. Just put 6 carbons there. 6 because of the hex. 1, 2, 3, 4, 5, 6. And then just make sure everything's got 4 bonds coming off of it. And then every carbon needs a hydrogen. Remember, the exterior ones are going to need 3, and the interior ones here, I'm just putting 1 up and 1 down, and then exterior, that one gets a 3rd. Okay, whew, this one's going to be a little bit nicer because prop means it's got 3, but ene means we're going to have to put in a double bond. And we're going to have to put that double bond, as you can see here, on that first carbon. So there's actually 2 ways to draw this structure. Let me go ahead and show you what I'm talking about. carbon 1, carbon 2, and carbon 1, right? They're both on the outside. Oops, you can't see me pointing at that. They're both on the outside, so either one of these could be the outermost carbon, either one of these could be carbon 1. This carbon here is in the middle. So one structure would be, let's go ahead and make that double bond here. I'm going to do the double bond first, just because that's going to influence how many other bonds I can make. So for example, the carbon in the middle here, you'll notice that it's got 1, 2, 3 bonds now. So all it needs is just one extra bond. This carbon on the outside here has 1, 2. So all it's going to need is 2 more. And then lastly, but certainly not least, my carbon over here is going to need 3. Let's put in the hydrogens. So the hardest part about this is just double checking to make sure that you don't put too many hydrogens in. It might be easy to think, oh, I'm going to need to add a hydrogen here and a hydrogen here because everything needs one up, down, side to side. But in this case, right, remember, we just want to have 4. So we're going to make sure that we do have 4 in this case. 1, 2, 3, and 4. Great. You could also draw this structure a little bit differently if you wanted. So this is just kind of one way to do it. Put that over to the side there. One way to do it differently would be C, C, double bonded to a C, and then it would look kind of similar, but again, a little bit different. So hopefully what you're noticing here is that it still has 3 carbons, still has a double bond on that between that outermost and innermost carbon, but then it's just on different sides. Over here, you know, it's on the left side versus over here, it's on the right side. Either way, kind of similar things. Okay, number 10 is going to be a little bit of a struggle. So let's first start by putting in the 7 carbons. And then I have a triple bond on I have a triple bond because of the YNE, and I've got that on my 3rd carbon. So first carbon, 2nd carbon, 3rd carbon, there it is. We'll put a triple bond there. And then what that's going to mean here is it's going to mean that these 2 carbons, they both already have 4 bonds, so they won't have any hydrogens on them. So hydrogens go here, but no hydrogens between these 2 carbons. And then these other carbons still get all their hydrogens. Let's just write them all in. And I'm not going to do it, but just like the previous problem, you could also put the triple bond over on 1, 2, 3, over on these 2 carbons. The triple bond could also go here. Okay, 1 ethyne, this will be easy, is just 2 carbons. And then it's got a triple bond between the 2 of them. So there's really only one location for that triple bond to go, right there in the middle. That was kind of nice. Okay, last one, 4-decene. All right, dec means 10. So let's draw in 1, 2, 3, 4, 5, 6, 7. Uh-oh. 8, 9, 10. Kind of ran out of room there. Okay, it's going to go on the 4th carbon. So here's carbon 1, here's carbon 2, here's carbon 3, here's carbon 4, and there's carbon 5. I don't know. I'm feeling like I'll just put it right here, just because I'm kind of feeling rebellious. I don't know if that ever happens to you, where you just feel a little rebellious. And then what I'm going to do is I'm going to put my extra bonds right on these carbons, just so that I know, okay, taking care of everything that's special, and then everything else is just going to get its usual, you know, up, down, and side if it needs it. And then now it's time finally to fill in all the hydrogens. So there it is, 12 problems, and it only took me a little bit of time. Just know that as you get more comfortable with this, eventually you'll kind of look like me, just bossing it. Hopefully this helps. Hopefully it makes you understand stuff a little bit better, and hopefully You guys have just a great rest of your day. Thanks for watching and take care.